Hello friends, this class is to explain the hypothesis test for population standard deviation. The prerequisite for this class is the videos for chi-square distribution. I hope you have seen those videos. Now, in our population mean hypothesis test, there were two cases. In one case where the population standard deviation was known, and in other case the population standard deviation was unknown. So this known case will be handled with this type of hypothesis test where we are going to check what can be the population standard deviation. Let's take a case here. There's a small business having 37 employees. Because of the uncertain demand of its products, the company usually pays overtime on any given week. The company assumed that about 50 total hours of overtime per week is required, and that the variance on this figure is about 25. So 50 is the average, and they assume that the population standard deviation will be 25 for this data. Company official wants to know whether the variance of overtime hours has changed, whether this remains as 25 or it has changed. Given here is a sample of 16 weeks, that's a sample size of overtime data in hours per week. Assume hours of overtimes are normally distributed, that's assumption. Use this data to test the null hypothesis that the variance of overtime is 25, and we are having level of significance, that is alpha as 0.1, and these are those 16 weeks data. So here our test is to check whether the population standard deviation is 25 or not. Let me show as a marker here as a pen. So this is what I meant is part. Okay, pointer option, marker, ink color, let me put it red. So this is what we want to check, is 25 or not. So let's go ahead. So we are saying, is the population variance, not sorry, variance is 25 or not. So that's the null hypothesis. If it is not, it's alternate hypothesis, so it's like equal to sign, so hence we have it's a two-tailed test. That's why I have written here two-tailed test. Now the chi-square distribution has a test statistics like z statistics or t statistics. In mean we have a chi-square here as a test statistics, which is given by n minus 1. N is a sample size, s square, that is a sample standard deviation square, so or we can say sample variance, divided by the assumed population variance. Because it's a two-tailed test, so alpha is 0.1, so half of that will be on left hand side and half of that will be on the right hand side. So we have 0.05 probability on the left hand tail and 0.05 probability on the right hand tail. Let's check in chi-square distribution table how to locate this. So chi-square distribution is this form, where like a normal distribution for any given value of the test statistics, that's a chi-square. What's the area towards the right of the value? And this is a table like t table. Here the structure is same. We have a degree of freedom on left hand margin and the probabilities on the right hand on the top margin, and the main section of the table here gives a chi-square statistics values. So for example, let's say if we have a chi-square value for, let's say we want to locate a chi-square value for degree of freedom 6, that's a sample size is 7, and let's say the chi-square statistics value is 12.59. So the area to the right of that will be 0.05. Now in our, and this, there's a small calculator available, you can make use of that, which gives you a probability for a particular chi-square value, or reverse way also, for a particular probability what will be the test chi-square statistics. Now in our case we have a sample size of 16, so degree of freedom is going to be 15, and our 0.05 area to the left of it and 0.05 area to the right of it. So if I take a 0.05 to the left of it, so my right hand side area will be 0.95. I'll show you that on diagram as well. So my test statistic will be 7.26. Let's look at the diagram. So we have 0.05 area on this side. So remaining area on this side will be 0.95. That's what I take here. And for that, the test statistics chi-square critical value is 7.26. That's here. Similarly, for the right hand tail, I have a 0.05 area and the chi-square critical value will be 25, which is given here. So now, if my test statistics computed value is between 7.26 and between 25, then I'm going to accept the null hypothesis. If it is lower than 7.26 or it is higher than 25, I'm going to reject it. So let's compute the test statistics. The data is, let's say n is 16. My s square I computed from those 16 reading is 28.06. So, and my assumed population variance is 25. I have plugged in the values here and I got chi-square is 16.84. Recollect that our critical values were 7 point something and 25. So since this value is between 7.26 and between 25, so we are failed to reject a null hypothesis. That's what our conclusion is. And hence we say the population variance of overtime is per week is 25. The result indicate to the company manager that the variance of the weekly overtime is about what they expected. It has not changed. You can do this practice problem. So where you please locate the sample size, the hypothesized value, and check whether it's a one-tail or two-tail test. Frame the hypothesis, calculate the test statistics, calculate the critical value, compare the test statistics with the critical value, and make a conclusion. If required, you can pause the video at this point, and once you have computed, you can compare the answer. The answer is given here. I hope this video will help you how to use chi-square distribution to check a single sample hypothesis test for population variance. Thank you very much.